Hello everyone. Today we are going to see the topic of basic analog communication systems. So first of all, you must know what is communication. Communication in the sense you are transferring the information from source to the destination. If the one more example of communication is while transferring message from transmitter to the receiver. So by definition, the analog communication which refers to the transmission of information through the continuous signals, so which can take one or more values in the given range. Today the communication systems, the basic concepts are signals, waveforms, amplitude, frequency and phase. So first of all, what is signal? So signal is the physical quantity which convey the information from source, light or voltage, etc. Then next one is a waveform. So waveform which contains shape of signals which over the time which is representing the graphical representation. So next one is amplitude. Amplitude is in the sense it's a maximum value of the intensity. Then frequency of the signal is a number of oscillations of the cycles. It can be measured in the terms of hertz. That last one is phase. The phase of the signal which is a timing relationship between two or more signals. So first of all, analog communication classification. So the main classifications are continuous waveforms, then AM, that is amplitude modulation, FM frequency modulation, then PM phase modulation. So first of all, continuous signal means is a continuous waveform that having the constant amplitude and frequency. Then the basic of AM modulation, amplitude is frequency amplitude modulation. So amplitude is varying accordance with the phase and frequency. That is amplitude of the modulating signal which is varying accordance with the frequency and phase. So next one is FM. FM is the frequency modulation. It's a technique where the frequency of the carrier wave is varied accordance with the information signal. So at last one is phase modulation. So PM is the phase modulation where the phase of the carrier is varied accordance with the information of the signals. So the information signal vary by the amplitude and frequency. These are the basic introduction of the signals. So next one is the basics of next one is the transmission path of the communication systems. So first one is the information source, then transmitter, channel, receiver, then destination. So information source having the voice, audio or speech signal. The signal can be transferring into the transmitter. So the transmitter having the transmitting antenna. The transmitting antenna which transmit the signal to the transmit signal through the channel. So from the channel then again given to the receiving antenna. So the receiving antenna receiving the signals and get back into the receiver. So finally the output will be generating in the output side of the receiver. So next one is the main important concept of communication systems is the modulation and demodulation. So modulation in the sense by the process of varying the characteristics of high frequency carrier in accordance with the instantaneous value of the modulating message signal or else the baseband signal. So message signal is one more term is known as the baseband signal or modulating signal. So modulating signal in the sense our message signal does not having that much of strength. So by adding some carrier in the message signal, so that time only the signal will be strengthened. So this is known as the modulating signal. So the process is known as the modulation. So next one is the demodulation. Demodulation in the sense is the process of separating the carrier. So we have to separate the carrier from the actual message signal, which is known as the demodulation. So next one is the types of modulation. So types of modulation, there are two types of modulation. So first one is continuous wave modulation, then pulse modulation. So continuous wave modulation having two main types. So first one is amplitude modulation, second one is angle modulation. So amplitude having only one type, angle having two types. So that is frequency modulation one more is the phase modulation. Next pulse modulation. Pulse modulation having two types. So one is analog modulation, then one more is the digital modulation. From that pulse modulation, analog modulation having three types: PAM, PWM and PPM. PAM is the pulse amplitude modulation, PWM is the pulse width modulation, PPM is the pulse position modulation. Then digital modulation having two types, that is pulse code modulation, at last one is the delta modulation. These are the main classification diagram of the modulation. So next, what is the benefits or what is need of modulation? The main need of the modulation, first one is to reducing the length of and height of the antenna. So for example, we having the signal having transmitting and receiving antenna. So the main important term to consider the modulation is the first one is the to reducing the length or height of the antenna. So second one is the for multiplexing. So the signal having multiplexing various types of antenna we are using in the basic need of modulation. So third one is the for narrow banding to use the antenna with single or same wavelength. So fourth one is to reducing the noise effect. Then last one is to avoid equipment in limitations or to reducing the size of the equipment. The five main types have been using for the need of modulation. So we must see one by one. So first one is the AM, that is amplitude modulation. So amplitude modulation of the carrier signal which varies with the accordance with the instantaneous amplitude of the modulating signal. So we have to see first one is the sine wave, that is the amplitude modulation. So second one is the carrier. So we have to add these two signals, the signal will be the final modulated signal. So we have to see carrier signal is C of t is equal to AC cos omega ct. We have to add these two signals where AC is the maximum amplitude of the carrier signal. So omega is 2 pi fc, so frequency of the carrier signal. So we have to add these two equations. The final equation is S of t is equal to AC cos 2 pi fct into 1 plus MA cos 2 pi fm of t. Next we have to find the modulation index. Next one we have to see the modulation index. So modulation index, the one more name is called as the depth of modulation. The main expression M of A is equal to maximum MA maximum minus MA minimum divided by MA maximum plus MA minimum. So the basic equation Vm divided by Vc. So this is the modulation index. Then there are three types of modulation index we are framing. So first one is the under modulation, then critical modulation and over modulation. The basic condition of the under modulation is modulation index value is less than 1. The critical modulation index value is equal to 1. The over modulation index value is greater than 1. Amplitude modulation. So next one is angle modulation. So we already studied the angle modulation can be classified into two types. So one is frequency modulation and one more is the phase modulation. So frequency modulation is the process of varying the angle of the carrier signal in accordance with the instantaneous value of the modulating signal. So from that angle modulation, the first one is frequency modulation. Frequency modulation in the sense frequency can be varying accordance with the fixed time of amplitude and phase. So phase modulation in the sense phase is varying accordance with the instant value of fixed amplitude and frequency. So next one is the frequency modulation. So what is the frequency modulation expression? The carrier signal C of t is equal to AC cos omega ct plus pi. So that is AC cos 2 pi fct. The omega can be replacing by 2 pi fc. So AC cos 2 pi fct plus pi. So next one, the frequency modulation diagram. So we must know, first of all we have know the basic of sine wave. Though we have to adding some carrier. So modulation index we have to find the frequency of modulating signal. So C of t is equal to AC cos omega ct. So omega I is equal to omega c plus kf of m of t. So in that we have to find the frequency deviations. Frequency deviation omega I is equal to omega c plus kf m of t. So omega c plus del omega. Next we have to find the phase modulation. So same expression you have to using in the phase modulation. So A Pm of t is equal to AC cos omega it. So omega I can be replacing into omega ct. So that is K P of m of t. So whereas Kp is the phase sensitivity factor in radian per volt. So next one is the frequency deviation. So frequency deviation you have to find the expression between the frequency to phase modulation and phase to frequency modulation. So at last we have to find the modulation index. So the formula can be using for the modulation index is frequency deviation by the maximum number of frequency. So MF is equal to del divided by FM. So FM value of modulation index is greater than 1 means we have to, the signal can be strengthened signal. So modulation index of FM can be deciding of bandwidth of the FM waves, the number of sidebands in the FM waves. So next we have to find the deviation ratio. Deviation ratio in the sense you have to know the ratio between the maximum deviation divided by maximum modulating frequency. So that is del max divided by F max. Next one is the percentage modulation. So percentage modulation equal to the ratio between the actual deviation divided by maximum allowable deviations. So this is the maximum number of deviations in the FM waves. Okay, that's all about the basic of communication systems. Okay, thank you.